Hello and welcome to Lesson 2-9. Today we're going to look at solving one-step inequalities by either adding or subtracting. So we're going to learn to solve one-step inequalities with subtraction and addition. And this is very similar to solving linear equations, which we just got done doing in the last unit. So let's take a quick look and see how to do this. Example 1 says to solve each inequality. And for the first inequality, we have n plus 8 is greater than or equal to 19. So just like when we were dealing with equations, if you recall, when we had an equation, something like n plus 8 equals 19, the first thing we would do is we would try to get n by itself, because this is our variable, and to do that, we would have to subtract 8 from both sides. So this is going to be the exact same approach that we take when we're solving an inequality. So the first thing I'm going to do is I'm going to subtract 8 from both sides, and my 8s are going to cancel, and I'm left with n, and I just rewrite my inequality. So n is greater than or equal to 11 in this case. And if you were to graph this on a number line, if we have 11, so here's 0, we'll say 5, 10, 15, negative 10. So what this would look like, 10, okay, would be an a closed circle, because it's an equals to. So we're going to put a closed circle on 11. And if you recall, our arrow then is going to go this way. So if I pick a test point, so I'm going to pick anything that is in the same direction as the arrow, so we'll say like number 15, if I plug that in as a test point and say to myself, is 15 really greater than or equal to 11? And because it is, that means I've done this correctly. Now likewise for part B, I have to solve the inequality negative 26 is greater than y plus 14. So in order to get y by itself, I have to subtract 14 from both sides. And here I have negative 40 is greater than y. Now you can either leave it like this, or I personally like to write my variable first. So I'm going to just reverse this, and because the pointed side of the inequality is pointing towards my variable, that means I'm going to make this y is less than a negative 40. And again, you could go ahead and sketch this out on a number line if you'd like. So here I have 0, negative 10, negative 20, negative 40, negative 50, and what this would look like then is I would have an open circle on the number 40, and my arrow then would be going to the left. So if I plugged in a number, so in this case, this number here is a negative 50. So if I say negative 50 is less than a negative 40, I ask myself, is that true? And I say, yes, it is. So that means I'm on the right track and this is correct. For example 2, it says that nearly 768 megabytes of memory are available for running your computer. If its basic system requires 512 megabytes, how much memory is available for other programs? So in order to write this inequality, we know that we're utilizing at least 512 megabytes. So I have 512 megabytes plus the rest of the megabytes that we're using. And I know that the maximum amount I can have is 768. So that means the 512 plus m has to be less than 768. So now you can see I have my inequality. And in order to solve, I'm going to go ahead and I'm going to subtract my 512 so I can get m by itself. And when I do that, now I'm left with m is less than 256 megabytes. So that tells me that the rest of the memory that's available for our other programs has to be less than 256 megabytes, otherwise it's not going to work. For example 3, it tells us to solve H inequality. Here I have n minus 15 is less than 3. So in order to get n by itself, I'm going to have to undo the subtraction of 15, which means I'm going to add 15 to both sides. So I have n is less than a positive 18. And that's my final answer for this one. And for part B, I have t minus 5 is greater than or equal to 11. So here, to undo the subtraction of 5, I'm going to add 5. And I'm left with t is greater than or equal to 16. This is going to complete the 2.9 video. Please let me know if you have any questions. Otherwise, have a great day.